Hi there, in this screencast I'm going to show you how to do model training using Keras and R. So in the last screencast we defined this single layer, this neural network with a single hidden layer with 100 hidden units for the spam data set. And we trained it using, we compiled the model by specifying the loss function, optimizer, the accuracy metrics here. Here I'm using the binary constant entropy or the log loss, using the stochastic gradient descent algorithm or optimizer, and the metric I'm using is just accuracy at every epoch. After that, I use fit to get on the training data, and I specify a certain number of epochs, a certain validation split proportion, and here I'm specifying verbose to get some output when I'm doing the training. So when I execute that whole chunk of code, I get some output that looks like this. For every epoch, I see how much loss and accuracy on the training set, how much validation loss and accuracy that's on the validation set I have. And then at the end, I do plot result. I'm saving the result of this model fit call in this variable called result. I do plot result, and I see that, well, as expected, the training loss is always going down, whereas the validation loss, well, it goes down up to a certain point, and then it starts to flatten out. Here, the minimum seems to be here around like 35, 38 epochs. Then it starts to go back up. And, if we redo the experiment, you'll see that the minimum is in a slightly different place every time. So it's stochastic gradient, so it's a little bit, so there's randomness, or picking random ordering of the samples every time. But here you see the training loss always going down, and here the validation is going down, down, and it flattens out, and here the local minimum is a little bit further out, around like 50 epochs. So to get a better estimate of the number of epochs, and what we can do is we can do a little experiment where we do this whole thing a bunch of times. So here let's add a for loop for uh, split I. So this is going to be a split indicator in 1 to say n splits, where n splits is 10. So we're going to do 10 different splits. We're going to do that experiment 10 times. Every time we're going to compute that model, plot the corresponding model, and we're also going to save it. So here I've got this, if you look at this result object, you see that it's a list of two things, params and metrics. Metrics is a list with all of these numbers that we're plotting in this figure over here. So loss, accuracy, validation, loss, validation, accuracy. Those are all these numbers here. And so, yeah, I mean, the important thing that we want to look at is the validation loss, because we're going to be trying to minimize that to select the best number of epochs. So what we can do is we can, here I'm using, I'm converting this list here to a data table by using this do call data table result metrics call. Here we get a metrics wide data table where it's all of these numbers again, but just arranged in this data table with epochs from 1 to 60 going down here. Here I'm going to add actually a column for epoch so we can see that more clearly. And then after that, we can think about storing this in a data table. Let's call it split metrics list. I'm going to initialize that as an empty list. Then I'm going to say split metrics list split I gets data table split I comma metrics wide. So what that's going to do is it's going to save it's going to save the data table in this split metrics list. So if we look at that, run that whole block of code, it's going to do that 10 times. Every time we're going to get a new list of metrics. A new kind of plot like this. Then at the end, what we're going to do is we can do split metrics gets do call rbind split metrics list. And when that computation is done, what we're going to have is we're going to have a better estimate of the number of epochs that we should use for training. Well, that gets the best result on the validation set. So we can summarize that. So split metrics, we're going to say mean val loss equals mean of val loss by equals epoch. And so that's going to give us, so here let's just execute that line of code. Split metrics is now this big data table with 600 rows, one row for every epoch and split. And then when we do this summary, so let's call it split means, this thing is going to be for every epoch, what was the mean across all of those 10 values? Right, so we could think about maybe calculating the SD as well. SD val loss equals SD val loss. Maybe instead of call that split means, call that split stats. Or split summary. Yeah, sure. Well, let's just keep split means. Who cares? Anyway, here we have this, and now we have the mean and standard deviation. We can plot that using a ggplot. Let's do that. First, we do library ggplot2. Library geom. Yeah, let's draw points like they have in the previous figure, just to emphasize the discrete nature of the data. And so it's going to be at x-axis, we're going to put the epoch. On the y-axis, we're going to put the mean val loss. Data equals split means. We can also add a geom ribbon for the error bar. AES x equals epoch. Ymin equals mean val loss minus SD val loss. Ymax equals mean val loss plus SD val loss. Data equals split means. And if we execute that, we're going to get this this picture. Well, let's use some alpha transparency. So that's semi-transparent now, so it's a little bit easier to visualize. So now we see actually that in these experiments, the best mean was achieved after only 3 epochs on average, which is maybe a bit surprising based on what we were looking at before. So maybe we can, let's do the experiment again, just to see what happens. And here I added a print here to see what the individual plots will look like. They're going to be showing up over here. So that's a bit unusual. That doesn't look anything like what we were seeing before. Yeah, I think what's happening is we're not reinitializing the model every time. So since we haven't, let's try that instead. So here, I think we need to use this model definition because I think this model object has mutable semantics. So here, let's put the model declaration inside of the for loop because I think what was happening is it's not restarting at 0 every time. So here, this looks like a bit more consistent with what we were looking at before. So you can see that every time it's kind of like the training loss is consistently going down. Validation loss, it's going to have like some minimum, which is it's jumping around every time. You know, here it's between 20 and 60 epochs every time. But what we're going to do afterwards is we're going to take an average using this split means here and this plot here, and that'll give us a kind of a more stable estimate about what the good number of iterations to use should be. Takes a little bit more time. Looks like this one, the validation loss is optimal all the way out at the end here at 60 or around 50 something. And now let's compute those summary statistics plots. So here, yeah, I mean, in this figure, it does look like the validation loss is pretty consistently going down. It doesn't look like it's going back up so much. So it might be good to actually increase the number of epochs that we use because we might have a minimum that's further out. So let's try that. Rerunning the whole experiment with 100 epochs instead of 60. And while we wait for that to happen, we could maybe code up a visualization of the minimum. So let's do that. So here, remember this split means, it's a table that looks like this. What we would like is to have some visualization of the minimum, which I'm calling a min dt, is a data table which contains the minimum. And in this data table, we're going to start out with split means, and here we're just going to take the min of mean val loss. So that should just be that one data point. So here, let's add a data point, geom point, AES, x equals epoch, y equals mean val loss. And here we can emphasize it, color equals let's say yeah, I guess we can just do this. I mean, actually, we want to color equals. So here we can add a variable here, data table. So or maybe min dt. Let's say point is min. So here we do color equals point, and here we'll do data equals min dt. And so that should draw a point and give us a legend for the color. So here's that visualization, right? So after going all the way out to 100 epochs, we see, well, the curve actually quite convincingly is going up now. Not very much, going up to 50 or 60, but then afterwards it's quite clearly going up. And in this experiment, after averaging over those 10 runs, we see that the minimum was achieved here at, let's look at our mean DT. It was achieved at 43 epochs. So that tells us that what we should do is we should go back to our whole data set and we should retrain our model using that number of epochs and then use that for computing our predictions on the test set. And so that'll be for the next screen, guys. Thanks.